Hey, 122. This is our first lecture. Hopefully any syllabus type questions have already been answered on the Blackboard page. I'm going to try and record just talking about math, so that this video is more reusable in case coronavirus lasts 30 years. How's it going? Let's get started talking about the calculus. We're in 2.1. We're skipping chapter 1, which is preliminary stuff. 2.1 is about derivatives. What is a derivative? I guess I'll give you a heads up that I'm cutting these videos off after 10 minutes. If I notice that I'm coming up to 10... YouTube doesn't let you do videos after 10 minutes until you do something. I don't know what the hoops are. I'm not jumping through them. If this video cuts off after 10 minutes, hopefully you've got the playlist turned on and it'll jump to the next one. But I'm probably not going to wrap up my thoughts unless I am smart enough to notice what's going on. We're talking about what's the derivative. Let's start with a good motivating example. Suppose there's a fly. And when a mathematician talks about a fly, what they mean by a fly is a point with no length, width, or depth, like a point moving around in space. And in this case, it's not even moving around in space. It moves in a line so that its position after t seconds is given by s of t is t squared. S is the traditional thing to use for position, which is annoying because we're about to talk about speed, and S doesn't want to be speed. Yeah, so there's like a ruler, right? And 0, 1, 2, 3, 4, 5. The points on the ruler are measuring space, but they don't measure time. Our time, such that at the moment t equals 0, here's our fly. He's flying this way. And at the moment t equals 1, he's here. This is because 0 squared is 0 and 1 squared is 1. But I guess the fly is speeding up, because at the moment t equals 2, 2 squared is 4. Our fly is at the 4-inch or centimeter or whatever the units are on our ruler mark. Actually, let's pick those units. Let's make this as in position in inches on this ruler. And our fly keeps moving along, whatever. We picked a really simple function, because we're going to plug a bunch of numbers into this function. And yeah, there goes our fly. And the question we want to ask, our first big motivating question in calculus, is at the moment t equals 2, how fast is the fly going? And you think about this for a second and realize it's kind of weird that this is a question you still haven't answered in any of the math classes you've taken. It feels like a really basic question. You do a lot of talking about rates and speeds and junk. Why have we never answered this question before? You think a little harder, and I have this theory that this was a much harder question for students 100, 200 years ago to even begin to contemplate. See, we have the major advantage that we drive cars. When I'm driving my car, I look down a little dial and it tells me that at this moment I'm going 38 miles per hour, say. And what does that mean to be going 38 miles per hour at a moment? I know what it means to be going 38 miles an hour for an hour. It means over the course of that hour it takes me 38 miles. It takes me an hour to go 38 miles. I can understand a little further than that what it means to go 38 miles for half an hour. It means I will get, 19 miles at the end of half an hour, and I'm going the same speed the whole time. But if I'm going 38 miles for a moment, then the distance that I travel in a moment, like distance equals rate times time, right? This is how we think about rates. So to work out how fast I'm going, I take the distance traveled and divide it by the time it took to travel that distance, and that gives me the rate. But if I want to know how fast am I going at a moment, then I'm asking in a moment, that's 0 time passing. And in a moment, I am moving 0 distance. So the rate is going to be 0 divided by 0? What is 0 divided by 0? Come on, Ben. If you haven't known, 0 over 0 is undefined. And it's undefined in sort of a special bad way. If I ask what 5 divided by 0 is, what I'm really asking is what is the number that when I multiply it by 0 gives me 5? And the answer is nothing. You can't multiply anything by 0 and get 5, so the answer to the question 5 divided by 0 is that's impossible. 0 divided by 0 is different. When I ask what's 0 divided by 0, I'm asking what is the number that when I multiply it by 0, I get 0. And now our answer isn't nothing, our answer is everything. It's still an undefined division. This is undefined. But it's sort of undefined in a different flavor than the way a number divided by 0 is undefined. 5 divided by 0 is undefined because there are no answers. 0 divided by 0 is undefined because there are too many answers. In calculus, at the start, this first couple questions of calculus, they do a lot of answering questions of the form 0 divided by 0. If you're doing a math problem and you end up with 0 divided by 0, there's a good chance one of the tools you learn in these next couple weeks is going to be the thing that helps you figure out what the real answer is supposed to be. So, how do we deal with this? Instead of asking this question at the moment t equals 0, which is a fundamentally hard question, we start by answering what's the question that we can answer. Question. In the 2 seconds following the moment t equals 2, how fast was the fly going on average? The question we're asking about is what's the fly's average rate of change over this period of time, which is a thing we can answer. You probably saw the words average rate of change in some algebra class. I'm going to abbreviate that AROC pretty often. Over the course of these 2 seconds, how fast was the fly going? Well, to answer that, I want to know where was this is the moment t equals 2 to t equals 4. I want to know where was the fly at the moment t equals 2. What is s of 2? What is s of 4? Our formula was s of t is t squared. 2 squared is 4. 4 squared is 16. We can answer this. Over the course of those 2 seconds, the fly moved 12 inches in those 2 seconds. So distance divided by time is 12 over 2 is 6. So the fly's average speed in those 2 seconds is 6 inches per second. We're answering that not because we think it is the correct answer to our original question, but this is the question we know how to answer, and it's probably in the right ballpark. We can do some fancier thinking and say, is the fly speeding up or slowing down? If I look at the sort of things that's going, it took him 1 second to move 1 inch, then he moved 3 inches in the next second, and then he's going to move even more than that in the next second. So I can see that the fly is speeding up over time. If you ask me if I know he was going 6 inches per second for these 2 seconds after the moment that I care about, and I know the fly has been speeding up the whole time, then this answer of 6 inches per second should be an answer that's too big, because this is how fast was the fly going over a period of time that he has sped up since the moment that I actually care about his speed. So I can not only say that 6 inches is not the correct answer, but I do know it's an answer that's too big. Our correct answer should be something less than 6, and maybe it should be pretty close to 6.